Welcome back, y'all. It's Mr. Jenkins. Tommy, get out of your chair. It's Mr. Jenkins with another Jenkivision video. This one, we're going to talk about an ACP question that you need to know, and I'm going to show you in real life the difference between a series and a parallel circuit. Let's get on this. This is a question that you'll see on the ACP. In which circuit does the ammeter, and remember yesterday we answered a question about what an ammeter is. What does an ammeter measure? Amps, which is what? Current. Go away! So the ammeter measures current. So this question asks, here's the ammeter right here, it's got the A. It asks, which one of these ammeters in each of these different circuits is gonna show the greatest current, the most current? Well, I got two types of circuit here. This circuit right here, series or parallel, America. Is this a series circuit or a parallel circuit, America? It's a series circuit. Is this a series circuit or parallel circuit, Chris? This one, aquí. Series. Is this a series or a parallel, Mac? Parallel. Chavez, is this a series or a parallel? Parallel. Good. Now, how do we figure out how much current is in each one of these circuits? Well, there's a law. There's a dude named Georg Ohm, and he created this law called Ohm's law. What is that Ohm's law? Dejanay. I know you know it.
F equals I over R.
F?
I equals V equals IR.
There she is.
That one.
V is equal to IR. V being the voltage, I being the current, R being the resistance. All I got to do is plug and play. Two big differences between the series and the parallel circuit. It's all about how we add up that total resistance. Let's do this. What is the voltage in this circuit?
1.5.
That's right, 1.5. 1.5 is going to equal to the current right there. I don't know it. And then the total resistance. What's the total resistance? The total resistance. 5.
Hello?
5. All right.
Hello?
Yes. Yes.
Can't you cross out C and D because when they parallel, everything is gonna be why the fuck are you going?
Yeah, because you're right. You understand there's a difference here. I'm calculating it. If you get the conceptual understanding, which we are getting to, you already know the answer. Now, let's get this calculation down. 1.5 is equal to I times 5. Somebody calculate what I is for me, please. Please.
Divide.
Yeah, we divide that by 5, that cancels out. So 1.5 divided by 5. The amperage is going to be how many amps? Let me know. Divided by 5. 0.3. 0.3 amps. We just did it. 0.3 amps. Let's go down to this one. Now, real quick. If I add more resistors, is the current going to go up or down?
Down.
It's going to go down.
It's gonna increase.
More resistance? Yeah, if the resistance goes up, I'm stopping the flow of electricity. Let's confirm. 1.5 is still my voltage. It's the same battery. But instead of, so I'm looking for I, current, instead of one 5 ohm resistor, I have 3 5 ohm resistors. What is the total resistance, y'all? 15. So, right here, what is I? I equals this, huh? 0.1 amps. So 0.1 amps. Which one has the most current out of these? A. For sure. For sure. For sure. Because this one has more resistors. But the question is, which one out of all these has the most current? And we got two parallel circuits over here. We're going to see. Do you think these are going to have more or less current?
More.
Huh.
Wait,
More
more.
less, because when you add them, you're gonna do it the inverse. You're gonna do
Did you watch the video, ma'am?
No, I was just here.
Because you were here for the last learning lab. Absolutely right. So let's check it out. I want you to see it first with the math. Look, same battery, 1.5 volts, providing my potential difference. I'm going to keep it right here. And that's going to equal the current, I don't know the current, I'm looking for I, times the resistance. Now, this is a parallel circuit. Am I going to be able to do 5 plus 5 plus 5?
No, you're gonna do have to do one
That
operator.
is right. That is right. 1 over a fifth plus 1/5 plus 1/5, which is what? What's the total resistance here? Okay, so 1 and 2/3, 1.66 repeating. All right, so now let's solve this. 1.5 is equal to the current times 1.66. If I divide both sides by 1.66, it's what? 0.9, okay? 0.9. The current is 0.9 amps. Now, what's up? Now which one has the most current? Yeah, right? Now, let's do this. Do you think this one's gonna have more or less current?
Less.
Ooh, let's check. All right, so we're gonna do V equals IR. The current is 1.5. It's gonna equal I, the current, times R. Is it 10? It's not, right? 1 over a fifth plus a fifth plus, that's just it. 2 resistors. Let's do it. What is this? 2 over 5, which is, decimal. 2.5? 2.5. All right, now that we know the total resistance, the equivalent resistance, let's solve for I. I is gonna equal 1.5 over 2.5, which is what? 0.6 amps. So we had 0.3 amps, 0.1 amps, 0.9 amps, and 0.6 amps. Which one has the most current? That's right. That's right. Because in these right here, if I add more resistors, the current is going to go down. These, if I add resistors, the current actually goes up. If I add more resistors, the current goes up. Do you not believe me? Watch this. Here we go. This is what I'm talking about. This is a 1.5 volt battery. It's a D cell. This is a 1.5 volt battery, right? This is a 1.5 volt battery. Check this out. I'm gonna take these conducting wires, they're called leads with alligator clips, and I'm gonna put them on this 1.5 volt battery, and I'm gonna light up this light bulb. Check, let's do this. I need you to help me out, Minor. No, I got more than I should. All right, let's do this. I want you to touch the bottom right there and the side right there, and watch what happens. Touch the very bottom. There you go. Now touch the side of it, that metal part. No. It's okay. Use this one. All right. Get where you can see. Check this out. Woo! It's sparking. Woo! It's hot. See that? All right. So look how bright this is. Look how bright this is. Now watch this. What happens if you do one and I do one? Look how bright this is now.
Which one? This one?
You do this one? Yep. Now, hold that. All right. You're gonna take that and that and light it up just how I did. Now, yep, there you go. Now watch the brightness.
Ain't no brightness.
Hold on.
Come on, man.
We're doing it. All right. You get yours.
I'm trying to. Why are you doing it?
It is. Hold on. I gotta get on mine. You're not touching it in the right place. Here. Touch it at the bottom, the very bottom, and on the side. Got it? With just the metal.
God.
All right. See?
I
You
did!
did it. All right, now check it out. Is it as bright as it was before when there was just one?
No.
No, because when I add in more resistors in series, the current goes down. It gets less bright. It gets less bright because I put more current in there. Now, I'm gonna show you a parallel circuit. I'm gonna put a bunch of in there. Check this out, watch. I'm gonna put a bunch of them in there. And I'm gonna light this up like this. Now watch this. The more I put in, it doesn't get less bright, it gets brighter. If I put more in, they all get brighter. Because the more bulbs I put in, the more resistors there are, the resistance actually goes down. It actually goes down. Some are burnt out because it's so strong. Another advantage of this parallel circuit is this. Go ahead and unscrew one of the light bulbs. Check it out. They all stay lit. You can take out any one you want. And it's still gonna work because there's multiple paths for this electricity to flow. That's that point of that parallel circuit. The more resistors I put in, right, the more current I have. On the other one, the more resistors I put in, the less current I have. It's calculated differently. On the series circuit, you just add them together. On the parallel circuit, you do 1 over the resistor plus 1 over the resistor plus 1 over the resistor. It's called a reciprocal relationship. Learn it, know it. V equals IR, Ohm's law. Say goodbye, guys.
Bye.
Bye, Pete. Hit like and subscribe.